Hi there, and welcome to the Science Lullaby. I'm really glad you're here. Tonight, we're exploring something incredibly small and unimaginably important, something that exists everywhere, at all times, shaping everything you've ever seen, touched, or felt. Atoms. They're invisible to the eye, silent and constant. Yet every breath you take, every thought you think, every star in the sky is built from them. Atoms don't rush. They don't struggle. They simply exist, following quiet rules that have guided the universe for billions of years. This video isn't about memorizing facts or solving problems. It's about understanding, slowly and gently, how the smallest pieces of reality behave and how their silent interactions give rise to everything around us. Atoms were here long before life appeared, long before planets formed, long before light reached your eyes. They emerged in the earliest moments of the universe, when space itself was young and unimaginably hot. Since then, they've been drifting, bonding, separating, and recombining, endlessly reshaping the cosmos. Every solid surface beneath you is held together by atomic bonds. Every sound you hear is the vibration of atoms passing energy along. Even the warmth in your body is the movement of atoms, quietly exchanging motion. Despite their importance, atoms are rarely experienced directly. We live in a world where their effects are everywhere, yet their presence remains hidden. And that's what makes them perfect for a calm exploration. They operate beyond urgency, beyond noise, beyond surface distractions. As we move through this story, we'll take our time. There's no destination you need to reach, no detail you need to remember. If you fall asleep, that's perfectly fine. Your mind will still absorb the rhythm, even if the details drift away. And if you stay awake, you'll begin to see the world differently, as a quiet dance of particles, endlessly interacting. Atoms are not static objects. They are active, dynamic systems. They vibrate. They attract. They repel. They respond to their environment in precise and predictable ways. Yet, when billions of them come together, they produce complexity that feels almost magical. Water flows. Metals shine. Living cells form and divide. None of this requires intention. Atoms follow simple rules, and from those rules, complexity emerges. This idea sits at the heart of chemistry. Chemistry is not about chaos or explosions. It's about order, balance, and interaction. Tonight, we'll begin by understanding what atoms are, not in a rushed or technical way, but in a way that feels intuitive and grounded. We'll explore how they're structured, why they behave the way they do, and how their quiet interactions shape the world you're resting in right now. As your breathing slows and your thoughts become softer, imagine the space inside and around you filled with these tiny building blocks, not as something distant or abstract, but as something deeply familiar. Because atoms are not separate from you, they are you. Every cell in your body is an intricate arrangement of atoms, organized with extraordinary precision. Every sensation you experience is rooted in their behavior. Understanding atoms is not about reducing life to something cold or mechanical. It's about recognizing the elegance beneath everything. As we continue, we'll move gently from this broad perspective into the inner structure of atoms themselves, exploring what lies at their center and how something so small can carry so much influence. For now, there's nothing to analyze. Just let the idea settle. In the next part, we'll begin to look inside the atom itself and discover how its quiet structure holds the foundation of all matter. To understand atoms more deeply, we can begin by gently stepping inside them, not by imagining something loud or explosive, but something surprisingly calm and ordered. At first glance, an atom might sound like a tiny solid object. In reality, it is mostly empty space. At the center of every atom lies a nucleus. This nucleus is incredibly small compared to the size of the atom itself, yet it contains nearly all of the atom's mass. Inside the nucleus are particles called protons and neutrons. Protons carry a positive electrical charge. Neutrons carry no charge at all. The number of protons inside the nucleus defines what kind of atom it is. Hydrogen has 1 proton, helium has 2, carbon has 6, oxygen has 8. This number never changes unless the atom itself is transformed into something else. It is the atom's identity. Surrounding the nucleus is a cloud of electrons. These electrons are much lighter than protons or neutrons and carry a negative electrical charge. Rather than orbiting the nucleus like planets around a star, electrons exist in regions of probability. They form a soft, shifting cloud where their presence can be predicted but never pinned down exactly. This uncertainty is not a flaw in measurement. It is a fundamental feature of nature at very small scales. Despite this complexity, atoms are remarkably stable. Positive and negative charges balance one another. Forces hold particles together in quiet equilibrium. The nucleus is bound by the strong nuclear force, one of the most powerful forces in nature. It holds protons together despite their natural tendency to repel one another. Electrons are held near the nucleus by electromagnetic attraction. Their negative charge is drawn to the positive charge of the protons. This balance of forces creates structure, not rigid, but resilient. Atoms can absorb energy. they can release it. They can shift into different states without breaking apart. This ability to change without collapsing is what allows chemistry to exist. Atoms are not isolated. They constantly interact with other atoms through their electrons. When atoms come close, their electron clouds influence one another. Attraction and repulsion shape how they arrange themselves. These interactions are governed by simple rules, yet their outcomes are endlessly varied. 2 hydrogen atoms and 1 oxygen atom can come together to form water. The result behaves nothing like its individual components. This transformation does not require intention or design. It emerges naturally from the structure of atoms and the forces between them. At the atomic level, everything is governed by probability rather than certainty. Particles behave like waves. Energy comes in discrete amounts. This quantum nature might sound strange, but it operates quietly beneath everyday experience. The solidity of the chair beneath you, the warmth of your body, the air filling your lungs, all are consequences of atomic interactions happening far below conscious awareness. Atoms vibrate constantly. Even in solids, they are never still. Temperature reflects how energetically atoms move. As temperature drops, atomic motion slows. As it rises, motion increases. This constant movement is not chaotic. It follows predictable patterns. Atoms seek stability. They arrange themselves in ways that minimize energy. This tendency toward balance underlies much of chemistry. Reactions occur because systems move toward more stable configurations. In this way, atoms behave almost patiently. They respond to conditions rather than forcing change. This patience is mirrored in the way chemistry unfolds over time. Some reactions happen instantly. Others take years, centuries, or longer. Rust forms slowly. Crystals grow quietly. Stars fuse atoms over billions of years. Atoms do not experience urgency. They simply follow the rules embedded in their structure. As you rest, these same processes continue inside you. Atoms within your cells exchange energy. Bonds form and break. Life maintains itself through countless microscopic interactions. You do not need to monitor any of this. The system runs on its own. Understanding atomic structure helps reveal why matter behaves the way it does. But it also invites a sense of calm. At the smallest level, reality is not frantic. It is orderly, rhythmic, and balanced. As we continue, we'll move from individual atoms to the ways they connect with one another, forming molecules, substances, and the materials that shape your everyday world. For now, let this image settle. A quiet nucleus, a gentle cloud of electrons forces in balance. In the next part, we'll explore how atoms bond together and how these bonds create the diversity of matter around us. Atoms rarely exist completely alone. Their true nature is revealed when they begin to interact with one another. These interactions are called chemical bonds, and they are the reason matter has form, texture, and behavior. Without bonding, there would be no liquids, no solids, no living systems, only isolated particles drifting through space. Bonding begins with electrons. Electrons occupy the outer regions of atoms, and it is these outer electrons that determine how atoms relate to one another. Atoms tend toward stability. This stability is often achieved when their outer electron arrangements are balanced. When an atom's outer region is incomplete, it becomes more likely to interact. Some atoms hold their electrons tightly. Others are more willing to share or release them. These tendencies shape how bonds form. One common type of bond is sharing. When atoms share electrons, they form a covalent bond. This sharing creates a stable connection, holding atoms together in a molecule. Water is a simple example. Two hydrogen atoms share electrons with one oxygen atom. The result is a molecule with properties entirely different from its parts. Another type of bond involves transfer. Some atoms give up electrons, while others accept them. This creates charged particles called ions. Oppositely charged ions attract one another, forming ionic bonds. These bonds create structured arrangements, often forming crystals. Salt is an example. Sodium and chlorine form ions that attract and organize into a repeating pattern. These bonds are not rigid. They respond to energy, environment, and temperature. They can form, stretch, and break. Bonding is dynamic. Atoms are constantly rearranging themselves, forming new combinations while releasing old ones. This constant rearrangement allows chemistry to be flexible. It supports change without destroying structure. The strength of a bond varies. Some bonds are strong and stable, holding structures together for long periods. Others are weak and temporary, allowing molecules to interact briefly. These weaker interactions are just as important. They allow substances to dissolve, proteins to fold, and biological systems to function. Even your body relies on countless weak bonds that form and dissolve every second. These interactions allow cells to communicate, enzymes to function, and life to persist. Bonding is influenced by distance. When atoms are close enough, their electron clouds overlap. When they move apart, the influence weakens. Temperature plays a role as well. Higher temperatures increase atomic motion, making bonds more likely to break. Lower temperatures stabilize connections. This balance explains why matter changes state. Solids melt. Liquids evaporate. Gases condense. All of these transitions are the result of changes in atomic bonding and motion. Despite their importance, chemical bonds are invisible. You cannot see them forming or breaking, yet their effects shape everything you experience. The firmness of the ground beneath you, the softness of fabric, the fluidity of water, all emerge from patterns of bonding. These patterns are not random. They follow predictable rules based on atomic structure and energy. Chemistry studies these patterns. It reveals how matter organizes itself and how change occurs. But beyond explanation, bonding invites reflection. Atoms do not cling. They connect when conditions allow and separate when conditions change. There is no resistance in this process, only response. This responsiveness allows systems to adapt. It allows matter to reorganize without conflict. In this way, chemistry mirrors the rhythms of nature: connection and release, formation and transformation. As you rest, countless bonds within you are quietly forming and dissolving. This constant motion sustains balance without effort. Nothing needs to be controlled. The system knows what to do. As we move forward, we'll expand this understanding further, exploring how collections of bonded atoms form molecules, and how these molecules give rise to substances with unique properties. For now, let the idea of bonding settle gently. Atoms connecting not through force, but through balance. In the next part, we'll explore molecules, the quiet architectures built from atomic bonds. When atoms bond together, they form molecules. Molecules are the smallest units of matter that retain the properties of a substance. They are quiet structures, built from atoms held together in specific arrangements. A molecule is not just a collection of atoms. Its shape matters. The way atoms are arranged in space determines how the molecule behaves. Even when molecules contain the same types of atoms, differences in arrangement can lead to very different properties. This is why structure is as important as composition. Molecules can be simple or complex. Some consist of just 2 atoms. Others contain thousands, arranged in intricate patterns. Despite this complexity, molecules follow the same basic principles. They form because bonding lowers energy and increases stability. They remain intact as long as conditions support them. Molecular shape influences how substances interact. Some molecules fit together easily, like pieces of a puzzle. Others repel one another. This selectivity allows chemistry to be precise. It enables reactions to occur in controlled ways rather than randomly. In living systems, molecular shape is especially important. Proteins fold into specific forms. These forms allow them to interact with other molecules in exact ways. A slight change in structure can alter function entirely. This sensitivity allows biological systems to be both stable and adaptable. Molecules are constantly moving. They rotate, vibrate, and shift position. Temperature influences this motion. As motion increases, molecules collide more often. These collisions create opportunities for reactions. Reactions occur when molecules rearrange their bonds. Atoms are conserved. Only connections change. This conservation is a fundamental principle. Matter is transformed, not destroyed. Molecular interactions are influenced by environment. Pressure, temperature, and surrounding substances all matter. Water plays a special role. Its molecular structure allows it to dissolve many substances. This makes it an ideal medium for chemical reactions. Inside cells, water provides a stable environment where molecules can meet and interact. Life depends on this quiet molecular dance. Outside living systems, molecules still follow the same rules. They form clouds, crystals, liquids, and gases. Air is a mixture of molecules moving freely. Liquids consist of molecules close together, sliding past one another. Solids are ordered arrangements where motion is limited. These states reflect differences in molecular bonding and energy, not differences in substance itself. Molecules do not intend to create form. They respond to conditions. Over time, this response leads to pattern. Crystals grow, minerals form, complex substances emerge. Molecular diversity arises naturally. There is no central control, only interaction. This diversity is what allows chemistry to produce such a wide range of materials. From soft tissues to rigid metals, all are built from molecular arrangements. Even materials that seem solid and unchanging are dynamic at the molecular level. Molecules vibrate and adjust constantly. This motion is subtle, but it never stops. Stillness is an illusion created by scale. Understanding molecules reveals how matter maintains structure while allowing change. It explains why substances behave consistently and yet remain flexible. This balance between stability and movement is essential. Without stability, structure would collapse. Without movement, change would be impossible. As you rest, molecules within you continue their quiet work. They maintain temperature. They support metabolism. They respond to subtle shifts. None of this requires awareness. The system operates continuously. As we continue, we'll move beyond individual molecules to examine how chemical reactions unfold over time, how energy guides transformation and drives change. For now, let the idea of molecules settle. Small structures, precise shapes, endless motion. In the next part, we'll explore chemical reactions, the gentle transformations that reshape matter without destroying it. When molecules interact, they sometimes undergo change. These changes are known as chemical reactions. A chemical reaction does not create or destroy atoms. Instead, it rearranges them. Bonds break, new bonds form, and matter takes on a new structure. This process follows a simple principle. Energy must be exchanged. Some reactions release energy, others require energy to proceed. The balance between these determines whether a reaction happens easily or slowly. At the molecular level, reactions begin with collisions. Molecules move, collide, and interact. Most collisions do nothing. Only those with the right orientation and sufficient energy lead to change. This selectivity keeps chemistry orderly. Without it, matter would transform uncontrollably. Temperature influences reaction speed. As temperature rises, molecular motion increases. Collisions become more frequent and energetic. This is why reactions tend to occur faster when things are warm. Cooling slows molecular movement, reducing reaction rates. Concentration also matters. When more molecules are present, collisions become more likely. This increases the chance of reaction. Despite these influences, reactions do not rush. They proceed according to natural constraints. Some reactions occur almost instantly. Others take years or longer. Rust forms slowly as iron reacts with oxygen. Photosynthesis unfolds steadily inside leaves. Geological processes reshape matter over immense timescales. Reactions follow pathways. They do not leap directly from start to finish. They move through intermediate states. These states are temporary. They exist only long enough for bonds to rearrange. Energy landscapes guide this movement. Reactions move toward lower energy configurations, seeking stability. Sometimes energy barriers must be crossed. These barriers prevent reactions from happening spontaneously. Catalysts help overcome these barriers. They provide alternative pathways with lower energy requirements. Catalysts are not consumed. They facilitate change without becoming part of the final product. Living systems rely heavily on catalysts. Enzymes speed up reactions essential for life. Without enzymes, biological reactions would proceed too slowly to sustain living organisms. Despite their speed, enzymatic reactions remain controlled. They occur only when conditions are right. This control allows life to maintain balance. Reactions occur when needed and pause when they are not. Outside living systems, catalysts also play important roles. They support industrial processes and natural cycles alike. Reactions are reversible in many cases. Bonds can form and break repeatedly. Systems move toward equilibrium. Equilibrium is not stillness, it is balance. At equilibrium, reactions continue in both directions at equal rates. The system appears stable, even though change continues internally. This dynamic stability mirrors many natural systems. Change occurs without disruption. Energy flow drives these processes. Chemical energy becomes thermal energy. Potential energy becomes motion. Energy does not vanish, it transforms. This transformation connects chemistry to physics and biology. It links molecular change to heat, light, and motion. In your body, chemical reactions sustain life. Energy from food is transformed into movement, warmth, and thought. These reactions occur quietly and continuously. They do not demand attention. The brain itself relies on chemical reactions to function. Neurotransmitters bind and release. Ions move across membranes. Awareness depends on these chemical processes, even though it feels separate from them. This connection highlights the unity of science. Atoms form molecules. Molecules undergo reactions. Reactions sustain systems. Nothing operates in isolation. As you rest, countless reactions unfold within you and around you. They maintain temperature, structure, and balance. There is no need to follow them. They proceed according to their own rhythms. Understanding reactions reveals how matter changes without losing identity. Atoms remain. Structure shifts. This quiet transformation is constant. It shapes the world without announcing itself. As we continue, we'll move beyond individual reactions to examine how patterns of reactions create larger systems, cycles that sustain matter over time. For now, let this idea settle. Change without loss. Movement full balance. In the next part, we'll explore chemical cycles, the repeating patterns that quietly sustain the world around us. Chemical reactions rarely happen in isolation. In nature, they are often linked together into repeating patterns known as chemical cycles. A chemical cycle is a sequence of reactions where the final products eventually feed back into the beginning. Matter moves through different forms, yet nothing is truly lost. These cycles give chemistry a sense of continuity. Instead of one-time transformations, matter is reused, reshaped, and redistributed. One of the most familiar examples is the cycle of carbon. Carbon atoms move between air, water, living organisms, and solid matter. They form bonds, break apart, and reform endlessly. Carbon dioxide in the air becomes part of a plant through photosynthesis. That carbon then becomes part of a sugar molecule. Later, it may be released back into the atmosphere through respiration or decay. At no point does the carbon disappear. It simply changes its surroundings. These cycles operate quietly and patiently. They do not hurry. They unfold according to environmental conditions. Chemical cycles are driven by energy, often from external sources. Sunlight powers many of the reactions on Earth. Heat from the planet's interior drives others. Energy moves through cycles, enabling matter to change form. When energy input decreases, cycles slow. When energy increases, they accelerate. Water also participates in cycles. Water molecules evaporate, condense, freeze, and melt. Throughout these changes, the molecules themselves remain intact. These transformations influence chemistry everywhere. They shape climate, geology, and biology. In living systems, chemical cycles are essential. Cells rely on tightly regulated cycles to maintain balance. These cycles manage energy, materials, and waste. One cycle feeds into another. Products from one reaction become inputs for the next. This interdependence creates stability. If one part of a cycle slows or stops, the entire system feels the effect. Balance depends on continuity. Despite their importance, cycles often go unnoticed. They operate beneath awareness over long periods of time. This invisibility contributes to a sense of calm. The world is supported by processes that do not demand attention. Chemical cycles also explain why matter can appear stable even as it changes. The surface may look unchanged, while atoms move quietly beneath. Rocks weather slowly. Oceans absorb gases gradually. Atmospheres evolve over millennia. These changes are subtle but persistent. In the body, similar cycles maintain internal balance. Chemical reactions regulate temperature, pH, and energy levels. These cycles adapt continuously. They respond to activity, rest, and environment. When cycles function smoothly, awareness feels stable. When they are disrupted, experience changes. Fatigue, illness, and stress all reflect shifts in underlying chemistry. Awareness mirrors these changes rather than causing them. Understanding cycles encourages patience. Change does not require force. It unfolds through repetition and balance. Chemical cycles do not strive for perfection. They adjust gradually. This gradual adjustment allows systems to persist. It allows life to exist within changing conditions. The elegance of chemistry lies in this balance. Simple rules produce complex stability. Atoms move through cycles without awareness. They do not resist change. They respond. As you rest, cycles continue inside you. Breathing exchanges gases. Metabolism processes energy. These cycles operate without effort. They have done so throughout your life. There is no need to intervene. The system knows how to maintain itself. As we continue, we'll explore how chemistry scales upward, how these cycles combine to create larger systems, and how chemistry connects to the materials and environments you interact with every day. For now, let the idea of cycles settle gently, matter moving without urgency, change without loss. In the next part, we'll explore how chemistry shapes materials, from soft substances to solid structures, and how atomic interactions create the textures of the world around you. As chemical cycles repeat and reactions connect, matter begins to take on recognizable forms. These forms are what we experience as materials. A material is not defined only by what it is made of, but by how its atoms and molecules are arranged. The same elements can produce substances with very different properties depending on structure. Carbon provides a clear example. When carbon atoms bond in one arrangement, they form graphite, which is soft and dark. In another arrangement, they form diamond, which is transparent and extremely hard. The difference lies not in composition, but in organization. This principle applies to all materials. Metals, plastics, wood, glass, and fabric are all defined by patterns of bonding and structure. In solids, atoms and molecules are arranged in relatively fixed positions. They vibrate, but they do not move freely. This creates rigidity. In liquids, molecules remain close together, but can slide past one another. This allows flow. In gases, molecules move freely and independently. They spread to fill available space. These states of matter reflect differences in bonding strength and energy, not differences in substance itself. Temperature plays a key role. As energy increases, motion increases. As energy decreases, motion slows. This explains why materials change state. Ice melts, water evaporates, steam condenses. These changes are reversible. They do not alter the identity of the molecules involved. Materials also differ in how they respond to forces. Some stretch, some compress, some shatter. These responses depend on molecular arrangement. Flexible materials have structures that allow movement without breaking. Brittle materials have rigid structures that resist deformation. Even softness and hardness are chemical properties. They arise from the ease or difficulty with which bonds can shift under stress. Electrical conductivity is another material property shaped by chemistry. In metals, electrons move freely through the structure. This allows electric current to flow. In other materials, electrons are tightly bound. These materials act as insulators. Thermal conductivity follows similar principles. Heat moves through materials via molecular motion and energy transfer. Materials that conduct heat well allow energy to pass quickly. Others slow its movement. Transparency and opacity also emerge from molecular structure. Some materials allow light to pass through. Others absorb or scatter it. These interactions with light give materials color, shine, and texture. None of these properties require intention or design. They emerge naturally from atomic interactions. Over time, humans have learned to shape materials by influencing chemistry. Heating, cooling, mixing, and reacting substances allows new materials to form. Metallurgy transformed societies by controlling atomic structure through heat and alloying. Glassmaking shaped light and space. Polymers introduced flexibility and durability. Despite technological complexity, the underlying principles remain simple. Atoms respond to conditions. Structure emerges. Natural materials follow the same rules. Wood gains strength from cellulose fibers. Stone forms through slow geological chemistry. These processes occur over vastly different timescales, but they rely on the same interactions. As you rest, materials around you remain stable, not because they are still, but because their structures are balanced. Atoms vibrate quietly, maintaining form without effort. This quiet stability contributes to a sense of safety. The world feels solid because chemistry supports it. Understanding materials as dynamic systems rather than static objects changes how they are perceived. Solidity becomes a pattern rather than a fact. Durability becomes balance. This perspective invites patience. Change occurs, but slowly. As chemistry shapes materials, it also shapes environments. The ground beneath you, the air around you, and the objects you touch all reflect chemical organization. These environments, in turn, influence chemistry. Conditions feed back into structure. This interplay continues endlessly. As we continue, we'll explore how chemistry connects to energy more deeply, how chemical bonds store energy, release it, and drive processes across nature. For now, let the idea of materials settle. Form arising from arrangement. Stability emerging from balance. In the next part, we'll explore chemical energy, the quiet force that powers reactions, systems, and life itself. Chemical energy is the quiet force that allows matter to change without falling apart. It is stored in the bonds between atoms, waiting to be released or rearranged. When atoms bond together, energy is involved. Some bonds store energy tightly, others hold it more loosely. This stored energy is not visible. It does not announce itself. Yet it shapes everything, from movement to warmth to life itself. When a chemical bond breaks, energy is released or absorbed. When a new bond forms, energy flows again. These small exchanges add up. They power reactions large and small. Fire is an obvious example. Chemical energy stored in bonds is released rapidly as heat and light. But most chemical energy moves much more slowly. It flows through systems quietly. In your body, chemical energy is released gradually. Food molecules break down. Energy is transferred step by step. This slow release prevents damage. It allows energy to be used efficiently. Cells rely on controlled chemical reactions to manage energy flow. They do not burn fuel. They transform it carefully. This control is essential. Too much energy at once would overwhelm the system. Too little would halt function. Chemical energy is also stored for later use. Bonds act like reservoirs. Energy remains available until conditions change. This storage allows systems to respond flexibly. Energy can be released when needed, conserved when not. Outside living systems, chemical energy shapes the environment. Fuels store energy accumulated over millions of years. Geological processes release energy slowly. Even sunlight becomes chemical energy through reactions. Plants convert light into stored bonds. That energy then moves through food chains. Energy always follows pathways. It flows from concentrated sources to dispersed states. This flow drives change. It powers motion, heat, and transformation. Yet energy never disappears. It changes form. Chemical energy becomes heat. Heat becomes motion. Motion becomes work. This continuity connects chemistry to physics. They are not separate domains. They describe the same processes at different scales. Energy also influences stability. systems tend toward lower energy configurations. This tendency explains why reactions occur spontaneously or require input. Equilibrium reflects balance. Energy flows equally in all directions. At equilibrium, change continues quietly. Nothing is frozen. Movement persists. This quiet motion mirrors rest. Stability does not require stillness. Understanding chemical energy reveals why the world feels both dynamic and reliable. Change occurs without chaos. As you rest, chemical energy continues to flow within you. Breathing releases energy. Warmth is maintained. None of this requires attention. The system manages itself. This reliability allows awareness to relax. There is no need to supervise chemistry. As we move forward, we'll connect chemical energy to the rhythms of life, exploring how chemistry supports living systems without directing them. For now, let this idea settle. Energy stored quietly, released gently. In the next part, we'll explore how chemistry becomes biology, how chemical processes give rise to living systems. At some point, chemistry becomes something more, not because new rules appear, but because existing rules begin to interact in richer ways. This transition is what we call life. Life does not require special particles or hidden forces. It emerges when chemical systems become organized enough to sustain themselves, respond to their environment, and reproduce. At the foundation of life are complex molecules. These molecules are built from the same atoms found everywhere else, yet arranged in ways that allow them to store information and manage energy. One of the most important features of living chemistry is organization. Molecules do not float randomly. They assemble into structures. Membranes form boundaries. They separate inside from outside. This separation allows internal chemistry to be regulated. Inside these boundaries, reactions are coordinated. Energy is directed. Materials are recycled. This coordination is essential. Without it, reactions would drift toward equilibrium and stop. Life persists by remaining far from equilibrium. This persistence requires constant energy input. Living systems are open systems. They exchange energy and matter with their surroundings. Chemical reactions inside cells are linked together into networks. The output of one reaction becomes the input of another. These networks create stability through balance. When conditions change, networks adjust. Reactions speed up or slow down. Materials are redirected. This adaptability distinguishes living chemistry from non-living systems. Another key feature is information. Living systems store instructions in molecular form. These instructions guide structure and function. This information is not conscious. It does not plan. It constrains. Molecules interact according to their shapes and charges. Information is embodied in structure. Replication is also chemical. Molecules catalyze the formation of copies of themselves. Errors occur occasionally, introducing variation. Over time, Variation allows selection. Chemical systems that persist become more refined. This process unfolds slowly. There is no sudden leap from non-life to life, only gradual increase in complexity. Life's chemistry remains grounded in the same principles discussed earlier. Atoms bond, energy flows, cycles repeat. What changes is scale and coordination. In living systems, chemistry becomes tightly regulated. Reactions occur in specific sequences. Timing matters. Enzymes play a central role. They guide reactions efficiently and selectively. They allow chemistry to proceed under gentle conditions. Without enzymes, life would not function. Reactions would be too slow or uncontrolled. Despite this complexity, living chemistry remains quiet. Cells do not announce their activity. They operate continuously. This quiet operation supports awareness indirectly. The brain itself depends on chemical stability. Neurons communicate through chemical signals. Neurotransmitters bind and release. Ions flow. These processes support perception, thought, and rest. Yet awareness is not present at the chemical level. Chemistry provides the foundation, not the experience. This distinction matters. Life is not consciousness. Consciousness emerges later from networks of living cells. Still, without chemistry, consciousness could not exist. Understanding life as organized chemistry reframes its mystery. Life is not separate from matter. It is matter behaving in sustained patterns. These patterns persist because they are supported by energy flow and structure. As you rest, life continues within you. Cells repair. Molecules rearrange. None of this requires awareness. The system knows its rhythm. This rhythm supports sleep. As awareness fades, chemistry continues its work. Life does not pause when consciousness rests. It maintains itself quietly. Recognizing this can be comforting. Even when awareness lets go, the foundation remains stable. As we move forward, we'll explore how chemistry extends beyond living systems again, shaping the environments that support life and influence experience. For now, let this idea settle. Life as organized chemistry, complex but grounded. In the next part, we'll explore chemistry in nature, how chemical processes shape air, water, and the environments around you. Chemistry does not remain confined to laboratories or living cells. It shapes the natural world continuously, quietly influencing the air you breathe, the water you drink, and the ground beneath you. The atmosphere is a vast chemical mixture. Gases move freely, collide, and react under the influence of sunlight and temperature. Oxygen, nitrogen, carbon dioxide, and trace gases interact in subtle ways. These interactions regulate climate and support life. Chemical reactions in the air break down pollutants. Others form protective layers that shield the planet. Water is another environment shaped by chemistry. Its molecular structure gives it unique properties. It absorbs heat slowly, dissolves substances easily, and supports countless reactions. In oceans, rivers, and lakes, chemistry unfolds constantly. Salts dissolve, gases exchange with the atmosphere, minerals interact with water over long periods. These processes shape coastlines, influence ecosystems, and regulate temperature. The ground beneath you is also a chemical system. Rocks form through reactions driven by heat and pressure. Minerals crystallize slowly. Over time, weathering breaks materials down. Water, air, and temperature work together. Atoms rearrange gradually. Soil forms through chemical and biological interaction. Organic matter decomposes. Nutrients cycle. This chemistry supports plant growth. Plants, in turn, influence chemistry by altering their environment. Roots release substances that interact with minerals. Leaves exchange gases with the air. Life and chemistry remain intertwined. Even landscapes reflect chemistry. Color variations in rocks and soil arise from oxidation and mineral composition. Rust-red cliffs, white sands, and dark volcanic rock all tell chemical stories. Temperature and pressure shape these processes. Deep underground, chemistry unfolds slowly under immense force. At the surface, reactions proceed more gently. Time plays a central role. Natural chemistry often operates on scales far beyond human experience. Change appears slow, but it is constant. This slow pace contributes to stability. Environments persist because chemistry unfolds gradually. Natural cycles link these processes together. Water carries dissolved substances from land to sea. Gases circulate through air and organisms. These cycles maintain balance. They buffer extremes. They allow life to adapt. As you rest, these processes continue unnoticed. Rain dissolves minerals. Winds transport gases. Chemical reactions adjust quietly. There is no central control. The system responds to conditions. Understanding chemistry in nature highlights its gentleness. Change does not require violence. Transformation occurs through steady interaction. This perspective can feel grounding. The world supports itself through countless small exchanges, rather than dramatic events. As chemistry shapes environments, it also shapes experience. Air composition influences alertness. Water chemistry affects taste and sensation. These influences are subtle but real. Recognizing this interconnectedness can soften awareness. You are not separate from chemical processes. You are embedded within them. This embedding supports rest. The world does not need to be managed consciously. Chemistry maintains itself. As we move closer to the end of this journey, attention turns inward again.
After exploring atoms, molecules, energy, life, and nature, we can now reflect on how chemistry quietly supports everyday experience. In the next part, we'll explore chemistry within daily life, not in a technical way, but as a background presence shaping comfort, warmth, and stability. Chemistry is often thought of as something distant or technical, yet it quietly shapes daily life in constant and familiar ways. Most of the time, its presence is felt rather than noticed. The warmth in a room is influenced by chemical energy stored in materials. Walls absorb and release heat slowly. Fabrics trap air, reducing heat loss. These effects arise from molecular structure rather than design. The softness of clothing depends on how polymer chains interact. Fibers bend because their molecular bonds allow flexibility. The sensation of comfort comes from chemistry responding gently to movement. The smell of air after rain is the result of chemical compounds released from soil. These molecules travel through the air and reach sensory receptors. Awareness registers them as freshness without noticing the molecular exchange. Taste is another chemical experience. Flavor arises when molecules interact with receptors on the tongue and in the nose. Sweetness, bitterness, and saltiness are interpretations of chemical structure. Even silence has a chemical dimension. Air density, humidity, and temperature influence how sound travels. The quiet of a space reflects the behavior of molecules absorbing vibration. Light interacts chemically with surfaces. Some materials absorb light, others reflect it. Color emerges from molecular arrangement rather than from light alone. Glass allows light to pass because its atomic structure lacks long-range order. Metals reflect light because their electrons move freely. These differences shape visual experience without drawing attention. Cleaning products work through chemistry. They dissolve, bind, and carry away substances, yet their effectiveness often goes unnoticed because they operate quietly. Cooking is a controlled chemical process. Heat alters molecular structure. Proteins unfold. Sugars caramelize. New flavors emerge. These transformations happen gradually, guided by temperature and time. Even breathing is chemical. Oxygen enters the bloodstream. Carbon dioxide leaves. This exchange happens continuously, without awareness. Sleep itself depends on chemistry. Hormones shift. Neurotransmitters change concentration. These chemical signals guide the brain toward rest. Melatonin increases. Alertness decreases. Awareness softens. The transition feels natural because chemistry prepares it. Stress also has chemical markers. Certain molecules rise in concentration, others fall. These changes influence thought and sensation. Calm emerges when chemical balance returns. Awareness reflects this balance rather than controlling it. Daily routines are supported by chemical predictability. Materials behave consistently. Environments remain stable. This reliability allows attention to relax. Even technology relies on chemistry. Batteries store energy chemically. Screens emit light through controlled reactions. These processes remain invisible. The quiet presence of chemistry supports modern life without constant maintenance. Systems operate until conditions change. Recognizing chemistry in daily life does not require analysis. It can simply invite appreciation. The world functions through countless small interactions. These interactions do not demand awareness. They allow awareness to rest. As night approaches, daily chemistry shifts. Temperature drops. Light fades. Hormonal patterns change. The body responds. Awareness follows these cues naturally. Thoughts slow. Sensations soften. The need to engage decreases. Chemistry prepares the transition to sleep quietly. There is no signal to notice. It unfolds on its own. This quiet support allows consciousness to release effort. The system knows how to rest. As we continue, we'll begin to draw this journey inward again, reflecting on how understanding chemistry can gently change perception and support relaxation. In the next part, we'll explore how awareness can rest within this understanding, allowing knowledge to fade into background comfort. As understanding settles, there is a natural tendency for attention to soften. Information no longer needs to be held tightly. Details can fade while the overall sense of order remains. Chemistry, when viewed this way, becomes less about facts and more about rhythm. Atoms move, bonds form and release. Energy flows steadily. There is no urgency in these processes. They unfold at their own pace, responding gently to conditions. This perspective can change how awareness engages with the world. Instead of scanning for meaning, it can rest within patterns that already exist. Understanding does not require constant focus. Once ideas are introduced, they can remain quietly in the background. The brain is designed to absorb patterns without effort. Repetition and rhythm support this absorption. As attention relaxes, sensory experience often becomes more subtle. Sounds soften. Breathing becomes slower. Muscle tension eases. These changes are supported by chemistry. Neurotransmitter levels shift. Hormonal balance adjusts. Awareness follows these shifts naturally. There is nothing to guide or direct. This inward slowing does not remove understanding. It changes how understanding is held. Ideas become impressions rather than tasks. Knowledge becomes comfort rather than effort. chemistry supports this transition. Stable conditions allow the nervous system to disengage from monitoring. When conditions remain predictable, vigilance decreases. Awareness no longer needs to track change. This is why familiarity can feel calming. Repeated patterns reduce uncertainty. Chemistry responds by stabilizing internal signals. As the environment becomes quieter, internal chemistry adjusts. Alertness decreases. Rest signals increase. The mind does not need to follow every thought. Thoughts can appear and dissolve without engagement. This passive awareness allows the brain to transition toward rest. There is no moment where sleep must begin. It arrives gradually. The chemistry of relaxation unfolds step by step. There is no command to follow, no action required. Breathing continues. The heart maintains rhythm. Cells regulate themselves. Awareness does not need to supervise these processes. They have always known how to proceed. As focus softens, the boundaries of experience become less defined. Time feels less important. Direction fades. This state is neither fully awake nor asleep. It is a threshold. At this threshold, understanding does not disappear. It becomes diffuse. Chemistry supports this diffusion by reducing sharp distinctions. Neural activity synchronizes. Integration becomes simpler. The sense of effort decreases. Awareness feels lighter. This lightness does not require emptiness. It allows experience to pass without attachment. As this process continues, the need for explanation fades. Patterns are enough. The world remains supported by chemical balance. The body remains supported by internal regulation. There is no need to hold on to the story. It can continue on its own. As we move toward the final parts of this journey, the focus will be on letting this understanding settle fully into rest. In the next part, we'll gently explore how chemistry supports deep rest and why letting go is a natural outcome of balance. Deep rest does not happen because the mind decides to sleep. It happens when the conditions that support wakefulness slowly dissolve. Chemistry plays a quiet but central role in this shift. Signals that once supported alertness begin to soften. Other signals gradually take their place. This change is not abrupt. It unfolds in layers. At first, attention loosens. Thoughts become less linear. Associations drift. This drifting reflects changes in neural chemistry. Communication between certain regions slows. Synchronization increases elsewhere. the brain begins to favor rhythms associated with rest. Electrical patterns shift. Energy use becomes more efficient. None of this requires awareness. It proceeds automatically. The body mirrors these changes. Muscles release tension. Breathing deepens slightly. These physical responses are guided by chemical feedback loops. When effort decreases, chemistry reinforces calm. When calm increases, effort fades further. This feedback creates a gentle downward slope toward sleep. In deep rest, chemistry does not stop. It becomes more focused on maintenance and repair. Cells take advantage of reduced activity to restore balance. Waste products are cleared. Resources are redistributed. This restorative chemistry operates most effectively when awareness is minimal. Attention consumes energy. Rest conserves it. Sleep allows chemical systems to operate without interruption. Processes that are less efficient during wakefulness gain space. Memory consolidation occurs through chemical changes. Connections are strengthened or weakened based on prior activity. These adjustments do not require conscious participation. They occur naturally. Hormones associated with growth and repair increase. Others decrease. This internal rebalancing supports long-term stability. It prepares the system for future activity. Deep rest is not empty. It is active in a different way. Chemistry works quietly to support recovery. The body becomes a stable environment again. This stability reduces the need for vigilance. Awareness no longer needs to track change. As a result, experience becomes simpler. Sensations blur. Thoughts lose urgency. This simplicity is not loss. It is a shift in emphasis. Understanding remains present, but it no longer needs to be held. It becomes part of background knowledge. This background supports safety. The system recognizes that conditions are stable. When stability is recognized, release follows. This release is the doorway to sleep. It cannot be forced. It occurs when nothing interferes. Chemistry ensures that this process is reliable. It has unfolded countless times before. It will unfold again. There is no need to monitor it. As deep rest approaches, awareness can let go of explanation. The story no longer needs to continue. Yet chemistry continues its work. Quietly, precisely. As we approach the end of this journey, the final focus will be on trust. Trust in these processes that sustain rest without instruction. In the next part, we'll gently reflect on this trust and how letting chemistry do its work allows rest to arrive naturally. Trust does not come from understanding every detail. It comes from recognizing that systems function without constant supervision. Chemistry has been sustaining balance long before awareness existed. Atoms bonded. Energy flowed. Cycles repeated. Life emerged within these patterns, not outside them. The body learned to rely on chemistry because chemistry is consistent. Signals rise and fall predictably. Responses follow conditions rather than intention. This reliability allows release. When awareness stops trying to manage processes it does not control, tension decreases. There is nothing to hold together, nothing to monitor. Breathing continues whether it is noticed or not. The heart maintains rhythm. Cells regulate themselves. These processes are not fragile. They are resilient. Chemistry supports this resilience through feedback. When systems drift, signals adjust. Balance is restored gradually. This gradual correction does not require intervention. It unfolds on its own timescale. Trust grows when awareness recognizes this autonomy. There is no need to assist chemistry. It already knows how to function. This recognition can be subtle. It may feel like a quiet easing rather than a thought. As trust deepens, attention loosens further. The need to understand diminishes. Understanding has already done its work. Now it can rest. This resting does not remove clarity. It changes how clarity is experienced. Clarity becomes a background sense of order rather than a foreground task. This background order supports calm. It signals that conditions are stable. When stability is perceived, vigilance fades. This fading is not weakness, it is efficiency. Chemistry supports efficiency by reducing unnecessary activity. Energy is conserved. Resources are redirected. As activity decreases, internal signals favor rest. This shift is gradual. There is no sudden threshold. Trust allows the process to unfold without interruption. Interruptions often arise from monitoring, from checking, from evaluating. When these behaviors soften, chemistry moves smoothly toward equilibrium. Equilibrium here does not mean stillness, it means balance. Balance supports rest without effort. As awareness becomes less engaged, experience simplifies. Sounds blur. Sensations lose edges. This simplicity is not emptiness, it is spaciousness. Within this space, chemistry continues its quiet work. There is nothing to improve, nothing to adjust. The system is already doing what it needs to do. Trust allows awareness to step aside. As we approach the final part of this journey, the focus will gently shift toward completion, not as an ending, but as a settling. In the next and final part, we'll allow the story to fade naturally, leaving chemistry to continue its work in silence. Everything that needed to be explained has already settled into place. Atoms, bonds, energy, cycles.
Life and rest are no longer separate ideas. They form a single quiet system. Chemistry does not stop when attention fades. It does not pause when awareness drifts. It continues with the same patience it has always had. Atoms keep moving. Energy keeps flowing.
Balance keeps adjusting. There is no finish line for these processes, only continuity. This continuity is what allows rest to arrive naturally. Nothing has to be held in place. Nothing needs to be resolved. Understanding can dissolve into familiarity. Familiarity can dissolve into calm. The smallest building blocks of the universe do not hurry. They do not resist change. They respond, adjust, and continue. The same principles apply here. Awareness does not need to stay alert to remain supported. The foundation is stable. Chemistry holds structure quietly. It supports warmth, breath, and rhythm without instruction. As the body rests, chemistry remains attentive in its own way. Repair continues. Balance is restored. There is no need to remain present for this to happen. The system does not depend on attention. This is why rest feels safe, because it is supported by processes older and steadier than thought. The world outside continues its chemistry as well. Air moves, water shifts, matter responds to gravity and light. None of this demands awareness. Letting go does not interrupt understanding. It completes it. What you've listened to does not need to be remembered. It does not need to be replayed. It can simply fade. Chemistry does not keep records. It moves forward without reflection. You can do the same. There is nothing else to explain, nothing else to follow. The story can end here, even as the process continues. Everything that supports you remains in place. You don't need to stay with the words. They can dissolve now. The quiet remains.